And as we have already discussed, security groups actually act as a firewall or virtual firewall for our instances to control inbound and outbound traffic. What does inbound and outbound mean? It means that inbound points to the incoming traffic or the requests that come into the host, and the outbound points to the outgoing traffic, which basically is the requests that are going from the host machine to the outside world. And as you can see in the diagram as well, we have the EC2 instance and the access is inbound and outbound. So by default, all the incoming rules are blocked to the EC2 instance, and by default, all the outbound rules or the outbound traffic from the EC2 instance is allowed. So you need to remember that you can't create rules that deny access. If you wish to block SSH, then simply you don't add a rule that allows it. Okay, and if you wish to have HTTP access, allow port 80 as a part of the security group. Okay, so there is no restrictions. You can add or remove rules at any time. And when we talk about security groups, there is a very important question that comes along, what is called connection tracking. So in EC2 instances, if you send a request from your instance, the response traffic for that request is allowed to flow in regardless of the inbound security group rules. That is what makes security groups stateful, and that is being achieved by connection tracking. So what it means is that security groups use connection tracking to track information about traffic to and from the instances. And the security rules are applied based on the connection state of the traffic to determine if the traffic is allowed or denied. For example, if you take ICMP ping command, you ping an instance where ICMP is added to the inbound security group rule. Okay, so information for that traffic is now tracked. So it is not considered as a new request, but rather it is viewed as an established connection to the instance, even if the outbound security rule has not allowed ICMP. Considering a security group name is unique to a particular VPC, this seems to be a bit unclear, isn't it? So let's check the example table here. So in the table here, we have both inbound and outbound rules that you see here. So we have the inbound rule and this is the outbound rule. Okay, so now one thing you need to note down is not all flows of traffics are tracked. As in, if the security rule permits TCP/80 port for all the traffic, and from the other end it allows all the outbound traffic, then the flow of traffic is not tracked. So if you see the example here, we have security rules for TCP and ICMP, where the outbound rules allow all traffic, and TCP traffic on SSH or port 22 here is tracked because the incoming traffic is not allowed for all IP addresses, even though all outbound rules allow the traffic. So if you see here, so the TCP rule that you see here is 22, so for SSH, and that is being tracked because the inbound rule states that any of the source IPs that are in this range are only allowed access using SSH, and that is why it is being tracked. But the TCP rule, HTTP 80 port, it has all the source IPs allowed in both inbound and outbound rules, so that is why it is not tracked, because it is both a bidirectional allow all traffic. And when you create the security groups, you can name them by anything that you want, but it should be unique within the VPC. So this is something we need to keep a note of. Okay. So let's again recap some of the most important points that we need to remember for security groups. So first and foremost, security groups actually control how the traffic flows to and from the EC2 instances or the machine. And they act like our virtual firewall. So by default, all traffic is blocked for inbound traffic. So remember that all traffic is blocked for inbound traffic, and all traffic is allowed for outbound traffic. Okay, so by default, when you create a EC2 instance, if you haven't provided anything, then the default security group allows all the traffic or all the requests that you send from your instance to the outside world. But the incoming is always blocked, but you can access the other resources. Okay, so the security groups are attached to a region and VPC, and security groups can be attached to multiple instances, and multiple instances can have a common security group. So you can create one security group and you can assign it to multiple instances as well. So the EC2 instances have no idea what's going on with the security groups. So it acts as a virtual firewall. So your EC2 instance level security is being maintained through the security groups, and we don't place anything within the instance itself to protect it from the incoming or the outgoing requests. We have that in place of the security groups itself. And we should actually always create a separate security group for SSH. So now let's get back to some of the basics before jumping onto the tough stuff. So we all know that there are different types of IP addresses, right? So IPv4 and IPv6, but we must also be aware of what are public and private IPs. So let's take a look at this example now. So these are the two web servers, and they are able to communicate over the cloud or the internet, that is the World Wide Web. But how? The thing that we see here is that they use public IPs. As the word suggests, public IPs are the IP addresses that can be accessed over the internet. And you can think of them as a mail number or a mailbox number which anyone can access to communicate with you. So if you have a public IP, anyone can access the data that you are broadcasting if they have sufficient permissions. And in your daily life, you are using Instagram, Facebook, YouTube, all these sites that have a public IP mapped to a DNS, or that is the domain name, which can be used to access the site. So naming your site is always better, because no one would remember the numbers, right? Remember a huge pile of numbers over a fancy name, isn't it? Let's take an example like Google. So it's fancy, isn't it? But what if you are in a private space like your office or your private home servers? Then things would be different. So if you see here, there is a private office internet space which has the provision to communicate within the organization or within its own network, but not the outside network without the help of the public internet gateway. And that is why we call them private. They have isolated scope to be accessed within the network, more so the office or the home network, and they can't be accessed globally. So you cannot access a private IP from outside its network until and unless you have a VPN connection to the network or something that you can grant access with. Okay, so what is the important thing that you need to remember here? So if you have a public IP, anyone can access the data that you are broadcasting if you have sufficient permissions. And just like you use in your daily life like Instagram, Facebook and YouTube, all these sites have a public IP that is mapped to a DNS name. You cannot access a private IP from outside its network until and unless you have a VPN connection to its network or something that can grant you access. Okay, so I hope this was somewhat of a clear understanding of how actually things work with public and private IPs. So let's move on. So now let's get some of the basic differences out for the public and private IPs. So the first thing is like IPv4 uses a 32-bit address scheme that allows you to store up to 2 to the power of 32 addresses, approximately 4 billion addresses. So on the other hand, we have IPv6. It is the most recently used of the IPv protocols. It uses a 128-bit address scheme that will not end in my lifetime at least. And IPv4 are numeric addresses like 192.23.12.2. separated by dot, and IPv6 are alphanumeric whose binary bits are separated by a colon, and it also contains hexadecimals. And as we have already discussed, a public IP is an IP address that can be accessed over the internet, that is mostly masked by a DNS like web server, email server, whereas private IP addresses of a system is the IP address which is used to communicate within the same network. That is the office space or the private space. And public IP are globally unique, but private IPs are unique over the local area network. And you might have to pay for a public IP, but private IP is usually your own and company managed. And these are the classes of IP ranges that we have for both the public and private IPs. So if you see here, we have for the public IP, we have class A, class B and class C. So the class A start from 1.0.0.0 to 9.255.255.255, and that ranges to 11.0.0.0 to 126.255.255.255. And public IPs can be geographically located, means you can go over the internet and find from where the IP has come from and who is the host, unless it is secured. But private IPs are private and you cannot find them online. Okay.